Welcome to Lesson 12.3, Solving Radical Equations for Algebra 1. So the first thing that we're looking at today is the idea of radical equations, which simply is the same thing as an expression, but now we have an equal sign added to the mix. Now, this note up here about the geometric mean, we will come back to at the end. So the 4 steps for solving for a radical equation are right here on the left. The first step is to get the radical alone. So whatever is underneath the square root symbol, we want to get alone. Then you simply square both sides of the equation. And then after that, you solve for the variable, same way you always have by working the order of operations backward. And in this process, you have to check your answer, because sometimes you'll get an answer that mathematically works until you plug it back in, meaning you can't have a negative resulting out of a radical or some other clauses. So sometimes the answer you get will not work when you try to plug it back in. So you have to check your answer, which we'll look at all 4 of these steps under example 1. So in example 1a, we have the square root of x minus 5 equals 3. The radical is already on its own because everything on the left is underneath the square root. So I move to step 2 of squaring both sides. So on the left, I square that, and on the right, I'm squaring 3. Then, on the left, the square root of x minus 5 squared simply gets rid of that square root. So the radical goes away, so we have x minus 5 equals, and 3 squared is 9. Then we need to solve for x, so we add 5 to each side, and we get x equals 14. Now, on a normal problem, that's where you would be done. But we have to plug it back into the original to check our answer. So we take 14 and put it into that original equation in place of x. 14 minus 5 inside the square root equals 3. Square root of 9 is 3, so the square root of 9 equals 3. So yes, the left and the right equal. So yes, 14 is a possible answer. If the left and right don't equal, then it could not be a possible answer, meaning we would have no solution. So now looking at B, I need to get my radical alone first, step number 1. So I have the square root of x minus 10. In order to get the radical alone, I have to add 10 to each side of the equation. That gives me the square root of x equals 10. Now I'm on to step 2, so I square both sides. Square root of x squared is x, 10 squared is 100. So x equals 100. Now we need to check by plugging 100 into that original equation. So the square root of 100 minus 10 equals 0. 10 minus 10 is 0. So does 0 equal 0? Yes. So x equals 100 is an answer. Now in C, that will be an example of a problem where we end up with no solution. So if we look at C, we have the square root of x plus 13 equals 0. First, we need to get the radical alone, so subtract 13 from each side. Square root of x equals a negative 13. Then we have to square both sides, and x would equal 169. Now when we plug that back in to check, the square root of 169 plus 13 equals 0. Square root of 169 is 13. 13 plus 13 does not equal 0. So in that case, C would have no solution. Moving to D. In D, we have to get the radical alone first, so we add our 7 to each side, and we have the square root of x plus 2 equals 7. Square each side, so we have x plus 2 equals 49. Then get x alone, so subtract 2 from each side, and x equals 47. Now we need to plug that back in to check. So take 47 and put it back into the original in place of x. So we have the square root of 47 plus 2 minus 7 equals 0. Square root of 49 minus 7 equals 0, which is 7 minus 7. So 0 equals 0. Yes, x equals 47 is a solution. And then we have E. In E, we again need to get the radical alone, so subtract 3 from each side. Have the square root of 2x minus 3 equals 1. Square both sides. 2x minus 3 equals 1. Add the 3. Divide by 2. And x equals 2. Then we need to plug that back in. So 2 times 2 minus 3 would be the square root of 1. Plus 3 equals 4. 4 equals 4. So yes, that is a solution. Now I left letter F blank for you. If you want to try your own example based on A to E, you can complete F, and if you're curious if you did it correct or not, feel free to shoot me an email and I can let you know if you did it correct or not. But F is an example you can try on your own. Then we get down to G, H, and I. G, H, and I are a little more complex because we have a variable on both sides. So in this case, if we end up with a variable on both sides, and we end up with an x or a y squared, that tells me I'm going to have to go back to that idea of factoring a polynomial or undoing FOIL eventually. So in this case, G, H, and I require us to add a couple other concepts from previous chapters. So first steps though, make sure the radical is alone. So in G, radical is alone, so we move to step 2 of square both sides. That becomes x plus 2 equals x squared. Now in order to undo the foiling, or factor our polynomial, we have to set it equal to 0. So we'd subtract the x from both sides, subtract the 2, and we'd end up with x squared minus x minus 2 equals 0. Then we can factor, so undo FOIL, and we'd have x minus 2 and x plus 1 equals 0. So to solve for x, we have to separate both binomials and get the variable alone. So x minus 2 equals 0. Add the 2 to each side, and x equals 2. X plus 1 equals 0. Subtract the 1 from each side, and x equals a negative 1. Now we have two answers to check. So we'll plug both the 2 and a negative 1 back into the original. So first on top here, I'm going to check the 2. Square root of 2 plus 2 equals 2. Square root of 4 equals 2. 2 equals 2. So yes, x equals 2 is a solution. Now checking the negative 1. Square root of negative 1 plus 2 equals a negative 1. Square root of 1 equals negative 1. 1 does not equal negative 1, so that's a no. So my only solution to this problem is x equals 2. So moving on to h, radicals alone, so we square both sides. 4x minus 3 equals x squared. We rearrange, so we get it equal to 0. So we have x squared minus 4x plus 3 equals 0. Now we need to factor that polynomial, x minus 3 and x minus 1. Set both equal to 0. X minus 3 equals 0, x minus 1 equals 0. Solve for x, so we have two answers to check, x equals 3 or x equals 1. You can see when I plug both of those back into the original, 3 equals 3, 1 equals 1, both work, so my final answer to h, x equals 3 or x equals 1. And our last problem is I. Again, in I, we first need to check to make sure the radical is alone, which it is, so we square both sides. 2x squared becomes 4x squared. Then, the square root of negative 8x minus 4 is just negative 8x minus 4. Rearrange so it equals 0. 4x squared plus 8x plus 4 equals 0. And then in this case, we can factor out the 4. So 4 times the quantity of x squared plus 2x plus 1 equals 0. Factor that trinomial, x plus 1 times x plus 1. On the outside, we still have the 4. Now, I know 4 cannot equal 0, so I don't need to worry about checking that. X plus 1, we have to set equal to 0, and that means x equals negative 1. We then plug that back into the original. We end up with a negative 2 equals a square root of 4. Negative 2 does not equal 2, so in this case, there is no solution. So going back to the top, the 4 steps here are very crucial. If you don't check your answer at the end, you may end up with an answer that works in the first part, but then when we plug it back into the square root, does not work. So make sure you go through all 4 steps. Then the last piece, which is not as big of a concept, but it shows up in some of your practice problems and next year in geometry, is the idea of a geometric mean. So if we think of a geometric mean of two numbers, so if we just call them a and b, the way we figure out the geometric mean is the square root of a times b. So an example, if the geometric mean of a and 6 is 12, what is the value of a? So we know a geometric mean is the square root of a times b. Well, I know it is 12, so 12 equals the square root of 6a. Then we need to solve the radical, so square both sides. 144 equals 6a. Divide both sides by 6, and a is 24.